when you guys were talking to me about how you were solving the bits and pieces, and I know that many learners, was it 415 take away 96, are happy with those methods. If they've got those well and truly ensconced, we wouldn't need to go any further. I'm not going to chase them down about that. Of course, with primary teachers, they need to be thinking a bit more deeply about that. With the partitioning strategies, perhaps suggesting that things like the empty number line, okay, and looking at tidy numbers around that, and 100 and 400, and saying, well, listen, I know there's 300 between here and here. I know that's 4 short there. And I know that's another 15. Together, what have I got? I've got my 319 as my answer. And I didn't really need to put an equals sign there. So maybe that's a way around it. So that, I know a lot of you have seen this sort of thing, but I don't think we should get away from the message of making it accessible. And if we took back what they were doing, a bit more tricky with this because this is getting a bit more formal mathematically, I try and say, well, what about having a thought per line? If you're going to give me something on paper, do your solving thought, put it on a line, and then do another solving thought and put it on another line, instead of the endless sentence stuff that came through. The other thing is this, I pointed a bit about algebraic reasoning. Something that might not seem evident to us, and in the research they talked about this sort of being, is it reflexive property? I can't remember. But this sort of thing here, we assume when we do equations sometimes, or do some working out, we suddenly change sides on them. And again, that's an assumption on our part that they suddenly will pick up on that cue. Classic case is this. I've had some learners say to me, I thought the A was over there. And what we found out was that they thought the alphabet, A, B, H, etc., played out this way from left to right. Why would you suddenly change that on me? They hadn't actually understood that rule. It disarms you when you think, my gosh, I've been saying this to them and they're going like this, and they're thinking, please don't ask me a question because I don't really know what you've just said, but I'll write it down anyway, faithfully. So this change of equation needs to be thought through as well. I think with transposing as well, and what's come out of this is this concept of equivalence. And I've always associated equivalence with fractions, but it's the big understanding behind the equal symbol. Equivalence is where it's at. Yeah. They're out there. So it's not just about a condition. Upstream is where they lose it if we don't get this bit right. We cannot assume that what we think someone might have seen before is obvious to them. Seeing is not learned. No matter how basic we thought. Who decided it was basic? But perhaps just in closing this little piece up here, there is nothing wrong with partitioning and oral presenting, etc., of solutions. My message is, if we're asking those tasks to be transmitted to paper, put onto paper, and submitted, or in whatever shape or form, or getting them to write it on the board or on screen, it has to be mathematically sane. Okay, and that's a bigger ask than I perhaps anticipated when I did this exercise. Now, I've seen this in the past with learners, the never-ending equals and string of bits and pieces. So it shouldn't have been a surprise to see the volume of people coming through in that particular class. More importantly, they're going to be primary teachers, so they have to get it right. They have to get it right. No question about it. Thank you very much for your time, and just start looking out for rogue equal signs, all right?